Still on section 2.2, it says to consider the following polynomial functions, okay, for g of x and h of x, and it says to choose the graph of each function from the choices below. So we're looking at which of the graphs will match up with g of x and h of x. Okay, first of all, if we look at, let's say for g of x, okay, here we have is equal to negative x to the fourth minus 3x cubed. All right, now we have for the highest degree term, let's say we have h dt, highest degree term, so we have negative x to the fourth. So we have, in this case, we have with the leading coefficient, a of n is equal to -1. So you have a negative, and we have for the degree n, you have n is equal to 4. So you have to end up being even. So we have, at least for the n behavior, okay, so you're going to have down to the left, down to the right. Okay, all right. So right now, let's say for the graph that ends up going down to the left and down to the right. So it's not going to be A, B, C, or D, but we still have possibly graphs E and F. So it's going to come down to either E or F. And so once again, we have with g of x equal to negative x to the fourth minus 3x cubed. So if I factor out the negatives, I have the negative of x to the fourth plus 3x cubed. And if I factor even further, greatest common factors, I have x cubed into x to the fourth plus 3x cubed. That's going to be at x plus 3 okay. So we have with the zeros. Okay, so you have with the x factor, okay, first factor, okay, we have x is equal to 0 from x plus 3. I have x equal to negative 3. And we have with the multiplicity, okay, x equals 0 has a multiplicity of 3, since that stems from x to the third. X equals negative 3 stems from just x plus 3, which you would say would be to the first. And correction, x equals 0 stems from x to the third, which in this case signals that 0 has a multiplicity of 3. And since we have odd valued multiplicities, you're going to have to cross at both x is equal to 0 and x equal to negative 3. So again, we have the in behavior have down to the left, down to the right, and we have at both 0 and negative 3. And so at negative 3, okay, this touches, but at negative 3, the graph is going to cross. So E is out of the picture, so we have F to be our result. So you have crossing at negative 3 and also at x is equal to 0. So in this case, all right, so for the first function, okay, the choice is going to be F. Now, for what we have in the case of the function h of x, so you have h of x, so we have negative 2 times, okay, the square of x minus 2. We have times quantity of x plus 2. Now for the end behavior, if I look for the highest degree term, okay, so you have with our factors, so you have negative 2 at the front, then we have x, which will be to the second higher degree term. We have in x plus 2 is going to be x, so I have for the highest degree terms, I have negative 2. We have times x, which will be squared, and we have times x once more. So we have negative 2 times x squared times x. Highest degree term, if you were to multiply out, we would have negative 2x cubed. So we have with the leading coefficient, we have negative 2. So that is negative. And we have for the degree of the expression, okay, signaled by negative 2x cubed, we have n is equal to 3. So you have to be odd. And if you have a combination of negative and odd, the end behavior is going to be up to the left and down to the right. So you have up to the left, down to right. So A is not possible, B is not possible, C, however, is, D is also possible, and graphs E and F are not possible. So you have up to the left, down to the right. And in terms of which of C and D is going to be the one that defines or represents the function h of x. So it's going back, so you have h of x, have negative 2 times the square of x minus 2. You have times the quantity of x plus 2. And we have, in the case of the zeros, from x minus 2, I have x is equal to 2. For x plus 2, I have x is equal to negative 2. And we have, now for the multiplicities, and so we have, for the multiplicity, we have x equals 2 stems from x minus 2, which is raised to the second. X equals negative 2 stems from x plus 2, which is to the first. Okay, so for x equals 2, the multiplicity is even. So you're going to have the graph to touch the x-axis at x is equal to 2. And since we have negative 2 with an odd multiplicity, it's going to cross at x is equal to negative 2. So crossing at negative 2 and touching at positive 2. Okay, now you have crossing at negative 2 and crossing at 2 for graph D. So A, B, D, E, and F are eliminated. So graph C in behavior have up to the left, down to the right. And we have crossing at x is equal to negative 2 and touching at x is equal to 2. And so the result is going to be graph C. And checking the result in this case, and while it's thinking, checking out, and the result is correct. Okay, for what we have in number 6, okay, we have this function f, and it's asking is decreasing over which intervals. It says to choose all that apply. Now the intervals, we're looking at the x values. Okay, so if you notice we have an increase since the graph is rising, then we have a decrease. And this is going to fall between but not including negative 8 and negative 5. So this is one location where we have the decrease, then we have an increase, until we get to x is equal to negative 1. And then once we look at this, we have decreasing again. So we have going past negative 3, approaching 3. And then we have, for the last decrease, you have between 7, but not including 7. And we have 9. Okay. Now, it says the function f has local minima at which x values. Okay. And what we mean by local minima, this is where we're going to have the dips. Now, if I were to look at the local maximum, like each maximum point, you're looking at the peaks. Now, for what we have in this particular case, where we have local minimum, looks like we'll have at negative 5, also at 3, and also at 9. Okay, so I have negative 5, 3, and 9. So just lining up. What we have here, so you have negative 5, 3, and 9. And in terms of the sign of the leading coefficient of f, remember the end behavior, you have down to the left, up to the right. So in this particular case, for what we have down to the left, up to the right, that means that, okay, we're going to have an odd-powered function. And in this particular case, all right, we're going to have the result to be positive. So you have a positive leading coefficient. Okay, and now just for what we have in the graph itself, I'm just going to mention, you're going to have in the illustration what will be referred to as turning points. And now for what we have here, so just sort of sketching the behavior of the graph of this particular function. Okay, now we have what will be referred to as turning points. So you have 1, 2, 3, 4, 5, 6. So you got 6 turning points. And now again, you have your A of n is going to be a positive coefficient. Now, for your value n is going to be odd. And it's going to be an odd value that is going to be more than the number of turning points. Okay, so the turning points will be, number of turning points will be at least one less than the degree of the function. So in this case, if you're looking for an odd value, more than 6 turning points, so n could be 7, 9, 11, and so on. And it looks like for the possible degree that we had to choose from, now we have an odd power function with 5, but that does not equal the number of turning points. So if it's equal to or less than, it's not included. But since 7 and 9 are values greater than the number of turning points, those would be the selections. And checking the results here, and that is also correct.